Feature Fridays. My name is Guy Bartram. I'm the Director of Product Marketing in our Cloud Services Business Unit at VMware. And for those who haven't met or know of Julian and Alex, I'm very pleased to be joined today by Julian De Silva and Alex Tanner. Let's start with a round of introductions, guys. Alex, why don't you go first?
Sure, Guy, thanks very much. Good afternoon, I'm Alex Tanner. I'm a Senior Staff Solutions Architect with the VMware Cloud Provider business in the UK and also involved in the Sovereign Cloud initiative.
Thanks, Alex. And Julian?
Hello, I'm Julian De Silva. I'm a Cloud Solution Architect in the Multi-Cloud Strategy and Architecture team, and my product specialism is VMware Cloud Director. Excellent.
Yeah, and we've done quite a lot of work on the Cloud Director topic on videos before, so thank you very much for your contributions to that. And Alex, your background is very apt for what we're going to talk about today. We're going to dive more into Gaia-X and Greenplum, because Julian, you have some interesting information about Greenplum that I personally hadn't heard before, and I think would make a really good session for our partners out there who are just curious about Gaia-X and actually what VMware is doing and how we're getting involved with some of the initiatives under it. So, sorry, Alex, do you want to?
Yeah, well, I was just going to add that it's also potentially a great showcase for aspects of the Tanzu portfolio that many folks may not be aware of. And obviously, one of the ongoing guiding principles that we have within the program is enabling our cloud providers to offer new services. And this is taking things in a new direction that may give them visibility of capabilities that they didn't necessarily know that we had, and that is becoming massively important and very popular with some of their end customers.
Absolutely. And you know, this is why I think it's such a good session to have. I mean, I was not aware of Greenplum at all, hadn't heard of it, you know, haven't heard of Pete. I mean, to be honest with you, we're all working hard, we're focusing on our own little areas, but this is definitely something that's very exciting. And as we look at, you know, the Europe vision for Gaia-X around monetizing data and data being the new economy, Greenplum certainly is one of the key differentiators I think that we have in our portfolio that providers should look at. So Julian, let's just start with really high level, just a reset. I've already done a session on Feature Fridays with Laurent, but let's just have a quick reset from yourself around very high level. What is Gaia-X, what it's all about, and why should service providers be looking at it?
So Gaia-X is an EU initiative, and it actually has government backing in terms of both interest and investment to establish a new digital architecture for the future economy of EU nations. So that means having a federated ecosystem where enterprises and consumers alike can place their data and share it securely and in a collaborative fashion in order to get the value. It's all about data sovereignty in the EU, but also getting the value from the data, as Alex mentioned. And the way to do that is to form a new reference architecture for all cloud partners within the EU to interact and interoperate and to set standards for how that ecosystem will work.
And that's where it gets interesting. Setting standards, interaction, interoperability is always a challenge and is going to be fairly verticalized, or imagine, in certain industries. And as much as we would love to have a common standard, it's never really been achieved. It's a very tricky thing to do. I mean, you know, I came from telecommunications background, and we had a lot of standards that we were trying to achieve then, and all hardware vendors do it differently. And there's always those, you know, slightly odd ones out. So how is VMware therefore getting involved in specifically, let's jump a pace here. Let's go straight to you know, Greenplum. So we've talked about it already. We've let the cat out of the hat. So Greenplum is what, Julian? Let's start with that.
So I feel like I should set the scene. So what I'll do is I'll start sharing my screen, if I may, and just give that a moment. And so to set some context, Greenplum is actually an open source product. It's been around for years. VMware is a lead contributor to that project. What we're looking at here is the Tanzu portfolio more widely. And the items you see selected in green form the Tanzu data services portfolio. So of course, VMware is traditionally known for the infrastructure layer. That's where we play well. We brought virtualization, multi-cloud abilities. But actually, we have a lot of capabilities in the data space, the data layer. Thanks to the Tanzu capabilities. We're trusted by financial organizations, by insurers, by healthcare to manage vast amounts of data in a secure and scalable way. So the items selected, I'll start from the left, work to the right very quickly. Gemfire is an in-memory data grid. So that's the kind of thing you'll find on a trading floor in finance, where now is not soon enough. All the transactions and the entire database, in fact, are stored in memory. And I think there was an independent review of performance, and I think it found that something in the region of 72 times performance compared to disk under typical enterprise circumstances. That's not 72%, that's 72 times the performance. So we're talking about millisecond transactions for enormous numbers of transactions for databases. Over to the right very quickly, RabbitMQ at the top is our message broker for enterprises. Very important for modern app architecture, where you have distributed applications across different clouds. Then Tanzu SQL is effectively VMware Tanzu's branded SQL product. So that's already your starting point for a database to store your data. And then finally, the one we really want to talk about at the bottom, which is Tanzu Greenplum. And you asked the question, what is it? It's a massive parallel processing database. So I'll go into that in a bit more detail. At the core of it, it's still all open source. It's based on Postgres. So you take Postgres, the database engine, and then you make it distributed across multiple systems. And just in a bit of context, the proposal that we're talking about here is to enable partners, service providers to build data platforms in which they have two core capabilities. One is the data lake, where you're effectively amassing and acquiring vast amounts of data of various structures, sometimes known, sometimes not known, and the data warehouse, where you have structured sets of data that you can then use in your database platform for various purposes. And the relevance here in Gaia-X, of course, is it's all about the data. Yes, the infrastructure is necessary, but the data is where it's at, and that's where the value is. So the volume of data we'll have to address is enormous. And then going to the right of the picture, we see our VMware Learning Platform, which is effectively being able to add various machine learning and deep learning frameworks available in the open source community onto the VMware platform using both CPU and GPU compute, using the Tanzu-based data platform as a source of data and, of course, a destination for processed data. So within the right-hand side, you could be talking about the development of machine learning models, looking at vast amounts of data that's been collected from IoT functions or perhaps metrics, telematics in cars, looking at traffic patterns, vast amounts of point data that can then be analyzed by various machine modeling tools. So we can come back to that later. You asked what Greenplum is all about. So here are your typical database architectures. On the left-hand side, you have your standard database instance of the vendor of your choice, and that's attached to a piece of storage. And so clients access the database, those requests are transacted in the database, and that will ultimately hit the storage. So the potential there is, of course, you have bottlenecks. So if you have multiple clients, multiple functions hitting one database instance, then you're hitting one storage platform. And of course, you can get premium storage to help address that challenge, but that still remains a challenge. Over to the middle one, which is traditional clustered instance. This has been around for years, of course, with various vendors of database, where you can create a cluster. And what you're still talking about here is effectively single instances of databases, but this time hosted on multiple systems. Sometimes it might be for failover purposes, so redundancy in the database layer, so that if one node is lost, the other can take over. And sometimes you can even get a higher level of intelligence where some of those nodes effectively act as read-only. So you can get a bit of scaling in terms of the amount of clients you can service. But at the bottom, you still have this challenge of having to use common storage because it's still one instance of a database. So Greenplum addresses the use case on the right-hand side, the parallel instance. So we take the database and there's nothing shared. In other words, each of the nodes you see take a portion of the data. So if I'm adding lots of rows to a Greenplum database, parts go to one node, then to another, and so on. And each of those nodes has their own individual storage. So there is no longer this shared storage. So what we're able to do now is parallelize the access to the database, but also bring in the other functions. So processing, the querying, things like stored procedures you have on a database and other functions, they're also processed in a distributed manner. So the query performance increases with the scale of your platform. And here's just to illustrate the fact that you have a database table in this example. It is truly distributed across that platform. So all of the nodes, which we call segments in the Greenplum world, participate. Now, the challenge it also addresses is if I talk about having, say, a clustered instance of a traditional database, you still have, say, one system which is making queries to that platform and placing a demand on it. And if you want to access the vast amounts of data and process them quickly, your database platform itself can become the bottleneck, because you only have that one instance or one clustered instance to process the data to respond to those queries. So another way that Greenplum addresses that is to have what we call frameworks and connectors. And they allow us to bring in other compatible tools. An example would be Apache Spark for massive analytics, where you actually align one-to-one the working components, the nodes, the executors, as you call them in Spark, with each node in the Greenplum database. So there's proximity. Imagine you have that split database across all of these nodes. Each worker is only processing its part of the database, so you get true distributed computing.
So I'm just looking at that Spark piece there, and I'm thinking that we've gone from like huge amount of parallel processing, distributed computing, as you said, across all of the nodes, and then you've added a little extra rocket on each node if you wanted to, with something like Spark, to be able to then say, right, you're only processing this subset of data, but I'm going to accelerate that processing with some executors for a specific function. And I'm guessing, Julian, those executors could be aligned to like a data transformation layer, for example. So we're receiving data, or we need to translate data and put it into our database. It's coming from a different connector, different source, different format, needs to be converted and then stored in our database. And that's, I think we're going to see quite a significant amount of that as these adapters and transformation requirements are exposed. As you peel back what the data world looks like, it's going to be like peeling an onion, isn't it? You're going to find tons of discrepancies within all of the data that people are holding, how they're holding it, what it means, and how they want to expose it and monetize it, and then how you take that and transform it.
That's exactly right. That's a very good point. So you have all this data in an enterprise, and sometimes the value is obvious. The structures of that data are known, so it's quite straightforward to set up mining and modeling and to access that data. In other cases, it's not so straightforward. And in some extreme cases, I've heard the term data swamp, which applies to just take any data, don't even look at the structure, and dump it somewhere in the hope that at some time you'll develop the capability to extract its value. And the one example I always think of is DNA analysis in criminology. Imagine, I think, I could be wrong here, I believe the first case where DNA evidence was used successfully in a legal case was in 1984. And effectively the technique to link a person to a piece of evidence was demonstrated and accepted in court in legal terms. Now, within the police force, they have a vast amount of evidence related to cases over many years. They were sitting on enormous amounts of case value that had legal implications, which they didn't really know about until that technique was brought about. So I see it in a similar way. And there are enterprises out there who are taking a similar approach to their data. Any data they collect, be it from customers or the operations they're performing in the business, they collect it in the hope that someday they can apply some artificial intelligence or machine learning to that problem, and then start to make innovations from that. And so you need something like Greenplum to be able to capture that data. And you mentioned the transformation use case, which is absolutely right. And so to aid you in that use case, I'm going to skip one slide forward. What we effectively propose here is an ETL production line. So the idea here is, working from left to right, you have data sources, and those are diverse data sources. They could be various database engines. You could think of any vendor or flavor you like, various structures, so different table schemas and so on. And even some of that data won't even be in a database. It could be text, it could be CSV, it could be XML, it could be printed information on forms. We helped a very large American insurer using OCR technology to effectively scan forms that were completed by customers and then effectively translate to a database. So on the left-hand side, you are submitting forms, you're scanning them, and then within the capabilities of Greenplum with various connectors, you're able to translate that directly into database rows, and that information is immediately searchable, indexable. So it's a huge challenge to address all of that. And so in this picture, the secure landing zone is where the data lands. Various techniques for acquiring the data and placing it somewhere in the first instance in readiness for transformation.
And can you talk a little bit, Julian, about the implications again around some of the concepts we've been talking about in terms of sovereignty? Because obviously that then gives you a separation that's critically important if the ingress of that data is being controlled by a sovereign body, and then it needs to be transformed, secured before it potentially can get shared out on, say, a public cloud platform.
Absolutely. So once the data is ingested, well, let's start with the first point. Your source of data, which is outside your platform, will probably have to remain confidential, most likely, and the owner of that data will want to ensure that their sovereignty over that is controlled. And so the first step is enabling secure connectivity to that data source and allowing that data provider to submit the data to the platform securely. So that's typically over something like a secure IPsec VPN tunnel. You could use NSXT for that use case. So that forms the first stage of secure networking to get the data onto the platform in the first place. The second stage, of course, is optionally, you can encrypt that data at rest. So in theory, that data could remain encrypted all the way through. If you have data encryption on the source database, it's entirely possible to extract it. So you would place the decryption password inside the platform in your own secure landing zone. And we are thinking about multi-tenancy in this case, where each customer can potentially provide their own. Then the data is transformed, and then even at rest within the data warehouse, it can also be in an encrypted form. And if not the entire database, it could be at the column or row level. So you could, for example, have encrypted columns or encrypted rows. You can have another form of security, which is data masking. So it's like a lighter version. It's not cryptography exactly, but it helps safeguard the access to the data. And once it's in the platform, you use security functionality, such as firewalling, micro-segmentation to ensure that data is kept secure at all times. Now, that's an interesting question because in the Gaia-X story, we're talking about a federated ecosystem where the rights of the data owner are always enforced. The sovereignty of that data is protected. So there are obligations on the service provider to enforce that. And if you imagine the ecosystem of multiple service providers within, say, multiple EU nations, the customer is free to move their data from one platform to another. So in that case, that sovereignty is maintained by maintaining that EU border. That's an objective of the Gaia-X platform. That's something we're looking very closely at and being able to solution in the platform itself.
And how does this deal with things like metadata? Because as you say, having these vast unstructured data sources is helpful in one way, but once you begin to transform it and understand it, you then want to be able to tag it for potential exploitation, further use, and additional information pertaining to how it can be used, where it's been used, almost introducing some element of classification and data lifecycle. Back to your point that from a sovereignty perspective, you may actually be asked to remove it and be able to validate that you have from your platform, even if your platform is potentially transit for that data to a different destination.
Absolutely. So within the Gaia-X framework, there is a proposal for how this would work. So one element of that is the federated catalog, the idea that the data owner can publish their data sets in a catalog which is accessible to all participants. And the conditions upon which that data is accessed is agreed in a kind of subscription. So perhaps the data could be free, it could be a gift to the world. On the other hand, it could actually be protected by contract so that the value gained from the use of that data is protected by legal contract so that the data owner ultimately has control over what is effectively IP. An example of that would be if you built a machine model and trained it with someone else's data. Who owns that machine model? Well, that's one of the challenges that Gaia-X is seeking to address. So again, by keeping those elements within the framework and within the ecosystem protected at the boundary, and there are tools in development to make that happen, that's possible. Other technologies that enforce that are things like blockchain. VMware contributed to VMware's Project Concord, and that's an open community. Anyone can contribute under the rules of that. And that allows for things like smart contracts. So you can build in the terms of your contract and you can authenticate it with a high degree of confidence in a distributed model. So there is no centralized database. It is in fact distributed across multiple platforms. And that can be a way of assessing access control rights to data.
Yeah, that's and I was looking at when you were looking at showing the slide with the distributed database and talking about the security requirements, my mind was thinking of blockchain and how apt blockchain is at keeping data spread over different environments and having having the encryption and decryption of the data done on the transaction by a third party. How would this then, So I'm just trying to think from a service provider's perspective. So our service providers typically provide platforms, right? They provide the infrastructure to run this stuff. You're going to have data sources coming inbound and going outbound, as you say, over IPsec or whatever encrypted communications there is. Are we seeing the role of the service provider as being a data platform provider, or are we seeing the role of the service provider to become the contractual owner for the services to provide things like the ETL processes?
That's a very good question. And it's in terms of obligations on the provider, potentially, and this really depends on which jurisdiction, you're talking about. So obviously with the EU, there is EU jurisdiction, and the data privacy regulations are actually pretty well developed. And so there could potentially be obligations on all parties, not just the data owner, but the data handler. That varies from place to place. Now, in terms of the role of the service provider, aside from potentially having to safeguard the rights of the data owner and and ensuring that the data is handled in a legal way, effectively the opportunity here, I think, is for the provider to basically offer that platform for data. What we do know is the volume of data that's going into cloud generally from enterprises is increasing. The importance and value of that data is increasingly recognized. And so the tools have to be out there. Now, at the moment, if you're, say, an EU enterprise or you're outside the US, you do have a dependency on US hyperscalers. And that's not necessarily a bad thing. In the multi-cloud story, you choose the right cloud for the right function. But there is potentially some uneasiness. Some enterprises may feel they want to keep their data local to them. So one way of doing that is to work with a local partner to provide data services. So as well as having this data platform to put your data in and to transform it, you then have frameworks to get equivalent services for things like machine learning and AI locally. Because the other, I suppose, challenge in terms of this is physics, data locality. If you're going to process data for machine learning purposes, you've got to be close to the source. There's no point having your database in Frankfurt and your AI learning tool in Paris. You've got to keep them together. So there's almost an inevitability that your data will travel for value.
And would that, I'm just trying to think, would you then bring the platform to the data source if you're able to deliver that edge compute value and have, the platform be inside the enterprise effectively?
And our basis for this is VMware Cloud Foundation, of course. You can deploy that in a very small deployment. So if you wanted compute at the edge for effectively what is data collection, a trusted platform with security that allows you to ingest security from the data from various sources and then pass it to a centralized platform. So effectively a data streaming use case where you're passing data constantly in high volumes into a central platform for collection and then processing later. So that decentralized model of collection versus centralized processing and warehousing is probably what it's going to look like. And then you might have duplicate data sets in different areas, different platforms potentially through replication, etc., so that other use cases for mining that data for value can also be applied.
So obviously Gaia-X has some quite specific requirements in terms of its principles. Key among those are things like reversibility and portability. In the kind of structures that we're talking about here, how is that guaranteed? Because obviously that raises a lot of concerns in the European context with the primacies you were talking about of the US hyperscalers of ensuring that as systems and services are developed that are beneficial to end customers and the suppliers, there is a situation should they need to move them and have that reversibility, portability, that's enforced in some way, or at least enabled at a technology level.
Absolutely. So our base technology is Cloud Foundation first. And then, of course, on top of that, we have our Kubernetes platform, which is basically Tanzu workload management. So the ability to manage both containers, which will become increasingly relevant here going forward, but also our legacy workloads and virtual machines are hosted on one common platform. Now that our Kubernetes interface is 100% compliant. It's basically based on open source standards. So there's full interoperability with tools and other platforms using the same capabilities. So the ability to move, say, a containerized workload and its persistent storage from one platform to another can be done exclusively with open source tools if necessary. You can use things like Velero, and there is a Tanzu flavor of Velero to effectively replicate container persistent storage. And then you can move that image by effectively replicating the images of the containers to your destination platform and then take the persistent data with it. There would be some hybrid use cases. So for example, you may distribute an application you have in one cloud provider and then start to host on another. Perhaps it's a partial migration, or that's your envisaged model, in which case you'll actually have stretched networking across the platforms. And in terms of the data layer, Greenplum, as I mentioned before, is open source. It's based on Postgres. So what that means is effectively, if you have an application or a tool set that talks to Postgres, it talks to Greenplum. It's the same approach, it's the same standard. And then in terms of interoperability with data sources, Greenplum can more or less ingest and acquire data from any source. So it understands Microsoft SQL, it understands Oracle, it understands other Postgres instances. And if you define the format, it can accept any kind of XML, for example. You just give it a schema and it can ingest it. So a high degree of interoperability and compatibility with various data sources and platforms for hosting.
At the point it's being ingested, though, it's, well, if you're looking at, I'm just trying to work out the encryption, decryption here. At the point of ingestion to a connector for Greenplum, the data would be either that connector is going to have to be local, and then it's ingested and somehow encrypted over at rest and in transit, or you would be dealing with encrypted XML by the time you got the connector, by the time it got to the connector. How's that working?
So there's a few ways of addressing that. So one is that a secure tunnel aside, so we make the assumption of in-flight that data is secure. You can encrypt the storage where that data lands into the platform. So it would be transitioning from one, say, encrypted source to an encrypted destination in terms of the storage. You can also include things like data masking or in-database encryption at the column and row level and take the key with you. So in that case, the data is always in an encrypted form.
Yeah, and there we're talking about, when we're talking about storage encryption, that is obviously kind of platform centric to whatever storage platform you're using. And it's encrypted data that has to be kind of decrypted on that platform. Whereas with the kind of architecture that I'm looking at here and the cryptographic mechanisms you'd be using, you'd probably want the data to be encrypted wherever it is, right? So whatever storage platform it ends up on, it's irrelevant. The data is still encrypted.
Yes, absolutely. So the data could be encrypted at the database level itself. So no matter where it's placed, it is encrypted. And then you have to effectively decrypt it at the client level to access the data once you've queried it. In terms of the storage platform, well, it's optional because, of course, the one thing with encryption is there is a performance hit. So the owner of the data, the consumer as well, has to decide if that's worthwhile. So you could have whole database encryption, which is costly in terms of performance, but may be necessary. You may have a selective encryption where certain privileged secure columns have to be encrypted, and you go from there effectively.
And there's no place here where tokenization may be considered. It is most likely to be encrypted throughout rather than tokenized.
It's unlikely to be tokenized in this platform in this current form. So within Gaia-X, for example, there is an architecture being discussed and work is being done to develop a connector for these data spaces. And in the first instance, it does some validation of the endpoints and it confirms authenticity. So it does a level of authentication. And then between the two endpoints, if everything lines up and we get green tick boxes, it opens up a tunnel for connectivity. So that's enabling connectivity between two trusted entities for a particular purpose. Now, blockchain can take it a stage further, where let's say, for example, in our federated ecosystem, we want to automate this entire process. So our data production line can be automated. The customer will create a landing zone through self-service for their data and send it. Blockchain can ensure that trust chain is maintained all the way through. So, for example, cloud provider B may have to cooperate with cloud provider A. Imagine the customer is moving from one to the other. The vision of Gaia-X is that one day this can all be done on a self-service basis in software. So a customer can just click online, get a contract with a provider, and then start moving their workloads to another. So in order to prove that that relationship, the legal relationship is in place between the customer and the providers, blockchain can achieve that.
Yeah, sorry, Alex, go on.
Yeah, just asking from a kind of a networking and security perspective, particularly if we see an emerging reliance on needing to have a commonality of principles of security throughout the life cycle and the transformation of this data. Are there any principles that you're seeing emerging in Gaia-X to try and deal with that? Because obviously, even down to networking standards, there's not a lot of commonality in many of these different providers. And if you're a person providing your valuable data or on behalf of, say, European citizens, you want some sort of guarantee that it'll be exploited under conditions you set and have some reassurance that, there's security around that.
Absolutely. So as part of the federated model, there is also the policy side. So I mentioned the federated catalog. That's not just the data, it's also for infrastructure services. So the idea in Gaia-X is that providers advertise their infrastructure services to the ecosystem. It's like a shop window. And they also advertise the characteristics. So it could be something like, we offer IPsec VPN services, and here are the various cryptographic standards we use, and here are the bit lengths. So if the customer is looking for a platform with a high level of security, they effectively build a shopping list of the characteristics they need. They build that into a policy and associate that with their data and their workload. So the workload can only ever be targeted at a platform that has those capabilities.
So somehow you're looking at some sort of registry where everyone's going to be publishing their capabilities.
Exactly, and it's most likely going to be distributed. So there won't be a central authority for any of this. It is a true marketplace, an ecosystem in true democratic fashion. And of course, the only way to make that work with trust and authenticity is with blockchain. Yeah.
And so there's I think an additional relationship there that I'm not sure that my knowledge of blockchain is pretty limited, but when we're talking about the contract, I mean, blockchain works on, if I'm right or if I'm wrong, correct me, the ledger system, right? So there's a distributed ledger. Here, we're going to require more additional information around the contract and legality of the contract and who owns what from the data and stuff like that. Is that something that, in your knowledge of blockchain, is possible?
My understanding is it is possible. So you can have a whole supply chain effectively, and it's all effectively about cryptographically witnessing that these participants have performed their tasks. And also revocation, of course. So if one party pulls out, you want to invalidate that entire chain. So that is a use case for blockchain. And in the Gaia-X use case, there are multiple personas set out. So you have the platform provider, you have service providers. Potentially, there could be intermediate providers. So an example would be you have the telco that provides connectivity to the data center is involved in the delivery of that service from the data center where you're hosting a workload. You then have the data owner, you have data consumers. So all of these parties have to establish contracts, and the idea is this is all done electronically, and then it's distributed using blockchain, so there's no centralized authority to manage it.
So there's kind of two sides to this. And if you go, there was a great diagram where you had the VMware stack at the bottom level, building up to Greenplum and to the connectors. So from a position here then is that there's two sides to this equation, really. There's going to be, well, three sides. There's storage and just data warehousing type stuff and data lakes. There's transformation and there's processing. And as a service provider today, most of them will be quite content with the storage and the processing. The transformation is going to be the piece where they're going to need additional relationships with smaller service integrators and specialization boutiques in different technologies to help them on their way. And we see this a lot now with analysts particularly saying to us that successful service providers of the future are going to be ones who establish partnering relationships and understand how to contractually support a customer, be that single point of contact for the customer, and then farm off the contracts at the back end to do the work necessary for the ETL process or whatever it is they're doing here. I mean, Alex, in your experience with some of the sovereign clouds you've worked with and what we're looking at here from a stack perspective, how do you see that playing out for a lot of service providers? Do you think they're going to be more content to stick at the infrastructure and how should they go about starting this journey? Because this is going to be a long evolution. This isn't going to be something that's going to, hit the road running and off you go. I can imagine, you're going to see certain industry verticals excelling at this and doing really well.
And I think that's exactly right, Guy. And I think it's the sort of thing where if there is emerging demand, if the service provider has existing skills in those verticals, knows the requirements. I mean, database as a service has been one of those things that we've been looking at and working with our service providers to try and give them an insight into, because that's an immediate value add. And this is, in some respects, that on steroids. So it's identifying where this could immediately be a sell. We have had several providers, for example, that have launched GPU services on the basis of believing their market was ready to consume them, only to find that after much investment and work and operational enhancements that they weren't. But I think there is time emerging in things like the Gaia-X initiative, interestingly enough, of which the UK is an active participant. This does raise the point of some interesting things, because we're beginning to see on the back of the pandemic, for example, a massive growth in awareness of the value that data can bring when you begin to collate it. And whereas previously there've been islands of it, we're now seeing a lot of initiatives to pool this data, and this type of architecture is fantastically important. The other thing, as Julian's emphasized, is you don't necessarily need to be the sole source of that data. There are opportunities to collaborate with other service providers with a common architecture to combine for different processing, different services, different initiatives, the relevant data that you have access to in the processing platforms. So we're looking, federation takes on a number of different meanings in this context.
Yeah, and I just also want to pull out the hyperscalers down the bottom there. I understand the fact that from a data monetization perspective and EU kind of focusing on Gaia-X, how does hyperscaler play versus really what I think, correct me if I'm wrong, but is the end game here to have more capability in localized service providers who can provide the compliance and controls that are necessary versus a single hyperscaler in a single region, for example, will not be able to necessarily provide the compliance and performance that another country might need. So do you see that as being very, very regional specific? I can use, I don't know, AWS because they're in London, I'm in UK, but I can't use them because I'm in Belgium, for example, because their nearest point of presence is Germany, maybe, or whatever it might be.
Well, certainly from my perspective, I'll defer to Julian as well, that it does, as you rightly point out, depend on the local regulations, jurisdictional requirements and whatnot. I can see a scenario, though, where in some territories of which, for example, the UK might be one, where there is a certain view on what it constitutes to effectively make that data available in something outside of the sovereign context, specifically of the soil of the country, and where there are certain sector verticals, certain portions of the government where that data could get extended into another area for processing and then either returned or be encrypted in such a way that the KMS is retained within our territory, the sovereign area, and then hence you retain effectively the security over the access and enablement of that data. So I think it, as you say, it does depend on territories and the extent to which federation and even sort of third-party synthetic use of the data is enabled by regulations and jurisdictions. In some cases, it's technology, but I think the actual regulations and outlook of the particular territory has a much bigger role to play these days.
Sorry, Julian, do you want to add anything to that?
Yeah, I completely agree with Alex's comments, and I'd just say that it is down very much to the fact that some data can happily pass through borders. So an enterprise, the reality for an enterprise, they are going to use multiple cloud providers. That's just how it is. And so it's about choosing which data lands where. Now, in some jurisdictions, it might be that having data overseas is a problem, particularly if the subject of that data are, say, individuals of the nation. It could be that they're not allowed to store it overseas. And the alternative, of course, is that hyperscalers also offer localized data centers, but even then, that may not be sufficient either if the ultimate ownership of the data center is a foreign power, a foreign nation. So depending on the circumstances, it may be that that forms a smaller part of an enterprise's cloud portfolio. And the other side of it also is the kind of services that hyperscalers offer, anyhow for data, the vast scale, the basically endless scale, and also some of the machine learning and GPU capabilities. Perhaps EU providers in other nations can offer those services within the data center at a more cost-effective way, particularly when you combine the need for things like managed services and consultancy. So if you go to a hyperscaler, they can give you the raw capabilities, but they won't help you with your problem. If you need that kind of relationship with a cloud provider, you may want to actually have that all under one house, under one roof, and have a provider who can help you through the whole chain, and even have that data locally as well. So in this picture, you can see machine learning frameworks in the top hand corner. It may be that there's various frameworks that the provider themselves within your nation actually has skills and capabilities, and they can offer you value that hyperscalers can't necessarily offer.
And I think one of the other interesting elements we've talked about is the need to track, have a life cycle and persistence and awareness of where data lives, how long, how many versions, and all of those good things. But one of the other technology elements we mentioned earlier were things like in-memory databases like Gemfire. So the alternative to that is situations where you're leveraging underlying technological platforms for doing the processing transformation on the basis that it is very transactional and the data isn't, as Julian alluded to, stored anywhere on that platform because it's in memory, for example, and is processed and then lost. And that then becomes a situation where you actually start dedicating functionality to certain platforms, where it literally serves as an engine, a bit like a render farm, to do the work, and then it's passed on to the next job. So there are lots of opportunities depending on the investment that different parts of the economy and industries are making on actually establishing platforms that transform data in a range of ways, some of which has massive lifecycle and sovereignty concerns, some of which will not.
And I think what I'm trying to get to for our viewers here is where, you know, this when I look at this, what I'm seeing is a stack, right? We've got a stack here, which is really a multi-purpose framework. And Alex, what you've just said, Julian, what you've said as well, for me, this is, you know, for service providers to get started on this world, you do what you're doing currently, right? Keep on with VCD, engage with Kubernetes particularly, because that's going to be super important in any case. But then there is the specialization. So if you are, you know, covering medical vertical, for example, and you got things like patient records, which you believe you can sell some of the, I know, radiology data to a private medical company, and you need to then have some specialization for GPU, for processing, for data transformation. You're probably going to want to go to a service provider who's got the relationships, understands, you know, that vertical already, has solutions in those areas, and it then becomes more of a specialized play. But what's really appealing to me now is we've got this VMware platform underneath, which pretty much will fit every single specialization at the infrastructure level. What you build in terms of the ETL, the connectors, and how you process the data is the differentiation.
Well, and I think one of the things that we've talked about and looked at in the past is the potential creation of certain marketplaces where some of these functions are genericized. And if you're in the medical sector and need to crunch vast amounts of, say, virus-related data, or in the construction industry looking at topologies and topographic data, or potentially, you know, in secure and intelligence and military needing to crunch vast amounts of telemetry data, there may be situations where you actually look for services, and within our service provider community, where there is some form of exchange that allows people to access spare resources to, again, back to the Gaia-X data space, combine these elements together to exploit them.
Yeah, absolutely. Well, listen, guys, I mean, I think this has been really enlightening for me because, you know, in the session before I had with Laurent, we covered Gaia-X and some of the principles around the data and the interoperability and how, you know, contractually that may look. This has been the next level down, which has been really interesting, actually looking at what is a solid architecture to suit most, if not all, potential use cases that you might come across, how cloud providers can start that journey, you know, having a repeatable framework, repeatable stack like Cloud Foundation is a very good way to scale in and scale out your underlying hardware layer with Cloud Foundation on top. And then obviously adding in the Kubernetes framework from Tanzu with VCD, some of the new improvements we made there. This is starting to me to feel like a very real thing that could be delivered by a cloud provider with a little bit more focus on the Tanzu data service layer. Okay, listen, guys, any final thoughts?
You first, Alex.
No, other than this as being a massive potential opportunity, because it's something where, particularly once we move Kubernetes into the mix, is potentially another framework that doesn't have dependencies into things like the individual implementations and the hyperscalers, an opportunity for the users of these platforms to align with the portability and reversibility that is now not just perhaps an option, but in some cases is legislated for.
And from my side, I think the data is becoming more and more important, it's becoming more and more relevant. And I think partners should look at these capabilities and see what value they can add to their portfolios to help their customers. I think there's enormous amounts of value. We've really just tapped the surface here. And the final slide that I'll show you to finish on is just some of the capabilities that are actually within the product itself. So these aren't bolt-on products you buy. If you've got Greenplum, you get language analytics, you get graph analysis, which is basically connecting the dots and understanding how things relate. Anyhow time series data, geospatial, asking the database a question, something like, I need to know how many devices are within 2 kilometers of X location. And finally, image recognition. These are capabilities and frameworks which are available as soon as the platform is deployed. So it's not just the data itself, it's the value you can extract from it. And I think that's the story to take away here.
Yeah, I mean, this is blowing my mind. I never realized this was all there. It's really good to see the framework that you've laid out today, Julian. Thank you for showing us and walking through it. I'm really pleased to see that firm foundation underlying it isn't changing, and it's going to give providers that opportunity to grow into the Gaia-X framework, not necessarily rebuild from fresh for Gaia-X, although some might like to do that obviously for different pods and different processing requirements. But fundamentally, they're building on their existing skills. And that, I think, is a really compelling, interesting argument. It's early days for Gaia-X, it's early days for a lot of these standards, but this is going to become a very real thing. You know, data will be the new economy. The EU is funding something like $64 billion, I think, behind it, or billion euros. And it's going to become more and more important as we move forward to address these, and at least for our providers to have an answer to how they participate in these frameworks. Gentlemen, thank you so much for your time. Really appreciate it today. And yeah, thank you again, Julian, for walking through that, and Alex for your commentary and thoughts on it as well. Cheers, guys.
Thank you.
Thanks so much.